Time is weird. Like, seriously. Have you ever stopped and actually thought about what time is? Not in an I'm late for work kind of way, but really thought about it. We all live our lives by it. We wake up because of time. We eat lunch because of time. We panic over birthdays because of time. We celebrate New Year's because somehow the planet did a circle and that feels like a good reason to drink champagne. But ask someone what time actually is, and they'll look at you like you just asked them to explain the plot of Inception. Backwards. Time is this thing we all agree exists, and yet no one really understands. It's like pineapple on pizza, or cryptocurrency. Even physicists, the people who name particles and launch billion-dollar lasers at each other, don't fully know what time is. Some of them think it's an illusion. Others say it's the fourth dimension. A few just quietly cry into their notebooks and pretend they're working on dark matter instead. But here's the weirdest part. Time, this mysterious, foggy concept that nobody can quite define, is run by math. Yep, time is basically just math pretending to be physics. Or maybe physics pretending to be math. Or maybe the universe is just one big clock that keeps glitching, and we're all stuck inside it trying to guess what time lunch is. But I'm getting ahead of myself. Let's start with a simple question. Why do we even measure time? I mean, other than the obvious reasons like knowing when to leave the house or when your cookies are done, what made humans thousands of years ago look up at the sky, see the sun moving and think, you know what this needs? Numbers. It's because time is slippery. It's invisible, but it pushes us forward. It never stops, but we can't catch it. And most annoyingly, it keeps going even when we really, really want it to pause, like in traffic, or during awkward small talk with your dentist. So to deal with this invisible force that never shuts up, we tried to trap it with tools, with logic, with math. We turned time into hours, minutes, and seconds. Things we can count and hold on to, little boxes we can live inside. But here's the twist. Every time we try to define time more precisely, it gets weirder. The more accurate our clocks get, the less time makes sense, because time doesn't like being stared at. It gets shy, it bends, it stretches, it dilates. Sometimes it doesn't even agree with itself. That's not just poetic, that's physics. But don't worry, we're not jumping into equations or black holes just yet. First, we're going to go on a little journey. A sleepy, cozy, occasionally ridiculous journey through time. Not through time like in a sci-fi movie, unfortunately, but through the history of time, through the people who tried to measure it, define it, fight with it, and occasionally got into academic fistfights over it. We'll talk about cavemen and shadows, about Egyptian obelisks that basically functioned as prehistoric wristwatches, except you couldn't wear them and you'd definitely stub your toe. We'll meet Babylonian mathematicians who cursed us all with the number 60, and Greek philosophers who overthought everything so hard they invented paradoxes by accident. We'll wind our way into medieval Europe, where monks invented clocks that were accurate-ish, but also terrifyingly loud. Then we'll meet Galileo, the guy who looked at a swinging lamp and went, "Hey, I just discovered time," and Newton, who tried to define time so seriously that he accidentally created physics as we know it. Kind of rude, but impressive. And of course we'll meet Einstein, the man who basically walked into a room, pointed at a clock and said, "What if it's lying to you?" Spoiler alert, it kind of is. But don't worry, we'll keep things simple. This isn't a physics lecture. You're not going to need a calculator, or coffee, or a PhD. Just an open mind, a comfortable place to sit, and a willingness to let your brain quietly unravel. Because here's the best part. You don't need to fully understand time to enjoy thinking about it. In fact, the less it makes sense, the more fun it becomes. Time is the ultimate cosmic prank. It runs the universe, but refuses to explain itself. It feels constant, but it's not. It feels obvious, but it's full of contradictions, and yet we built our entire civilization around it. Cities, calendars, cooking shows, all of it, powered by time. And the engine behind that power? Math. Invisible, silent, quietly smug math. Time is numbers pretending to be meaning. It's equations dressed up as experience. It's clocks and calendars and countdowns, all just clever little tricks we invented so we wouldn't feel lost in the endless now. So, in this video, we're going to explore that beautiful absurdity. We'll laugh at ancient math mistakes that still live on in your kitchen timer. We'll dive into stories about monks, emperors, scientists, and probably at least one goat. We'll untangle time with jokes, not formulas, with curiosity, not anxiety. And by the end, maybe, just maybe, you'll fall asleep. Not because it's boring, but because it's cozy. Because time at its core is just a lullaby we tell ourselves so the universe doesn't feel so loud. So get comfortable, take a deep breath, let your thoughts drift, because chapter 2 is coming, and it starts with cavemen and stick, because of course it does. Cavemen and shadows. Before there were clocks, before there were calendars, before there were Mondays to dread and meetings to miss,
There were cavemen.
and shadows.
That's it. That's the entire concept of timekeeping for, like, thousands of years. Just cavemen, staring at shadows, probably while grunting, maybe while inventing fire, definitely while wondering why the sky kept changing. Let's picture it. You're a prehistoric human. You've got no clock, no phone, no alarm, no emails, just a stick, a rock, and the vague feeling that it's getting dark and you should probably go hide in a cave before something with sharp teeth eats you. So how do you know what time it is? You look at the sky. You notice that the big fire orb rises, moves and disappears. And maybe, just maybe, you realize it does that. Kind of the same way every day. That's time, baby. The sun moves. The shadows move. And somewhere deep in our ancient brains we go, ah yes, day, night, day again. Something is happening here. And so begins the first math problem in human history, trying to predict the future based on the position of a shadow on the ground. Now, let's not pretend early humans built observatories or did trigonometry. They were mostly just guessing. But over generations, they started to notice patterns. The sun comes up, hits that rock over there, around the same time every morning. The moon disappears for a while, and then comes back full and shiny every so often. The seasons keep cycling. Cold, warm, bugs, cold again. Rinse and repeat. And over time, no pun intended, people realized these cycles weren't random. They were connected to the sky. The sky was a giant cosmic clock, a very slow, sometimes cloudy, occasionally terrifying clock. So naturally, humans did what we always do when faced with the unknown. We tried to control it. The first tools of time were probably just lines in the dirt, maybe a pile of stones, or some bones with notches carved into them, marking the moon cycles. Archaeologists have found bones with 28 little cuts in them, possibly the first ever lunar calendars, or maybe some very organized person, keeping track of how often they stubbed their toe. Either way, it's date, but eventually, we moved on to sticks. Yes, the stick. The humble, world-changing stick. If you plant a stick in the ground and watch its shadow move throughout the day, congratulations, you've just made a sundial. A really bad one, but still, technically a sundial. The shadow gets shorter, then longer, and moves in a circle. Not because the sun is moving around us, but because the earth is spinning. Of course, prehistoric humans didn't know that. They thought the sun was the one doing laps. Honestly, it does look like it is. We can't blame them. But by watching shadows, they could start to break the day into parts. Morning, noon, evening. Shadow over here. Time to hunt. Shadow over there. Time to nap. Shadow gone. Probably get inside before a saber-toothed tiger shows up. This was timekeeping at its purest. No batteries, no ticking. Just light, shadow, and survival. Eventually these simple observations turned into rituals. Farmers began planting crops based on when the stars rose.
Ancient tribes built stone circles that aligned with solstices. And suddenly, we weren't just reacting to time, we were predicting it. That's where the math sneaks in. See, to predict something, you need to measure it. To measure something, you need numbers. To use numbers, you need patterns. And once you start chasing patterns, you're doing math, even if you're covered in mammoth fur and still think thunder is the sky yelling at you. So even though cavemen probably couldn't do long division, they were already laying the groundwork for what would become thousands of years of mathematical time obsession. And it was all because they watched a shadow get longer in the afternoon and thought, that happens a lot. One of the earliest examples of humans trying to get serious about this comes from around 20,000 years ago. In what's now France and Africa, archaeologists found bones and stones etched with marks that suggest moon cycles. That's months. Moons. The beginning of the calendar. Fast forward a few thousand years, and now we're building things like giant stone monuments, like Stonehenge, which, let's be honest, looks like a place where a druid rock concert would happen. But it's actually a very early, very massive clock. Stonehenge is aligned with the sun's position at the solstices, meaning if you stand in the right spot on the longest or shortest day of the year, the sun rises or sets perfectly between the stones. It's ancient timekeeping with rock. And that's where we really see the shift. From watching the sun because it tells us what time it is, to building massive monuments that prove we understand what time is doing, or at least that we're trying really hard to impress the sky. So why does this matter? Because every single clock we use today, from your microwave to the atomic clocks used by NASA, is built on the same basic idea that time is just a repeating pattern, something we can observe, measure, and eventually count. And it all started with shadows. A stick, a rock, a curious human trying to make sense of a day that just wouldn't sit still. So next time you look at your watch or check the time on your phone, remember, you're just participating in a very long tradition of people being extremely confused about why the sun keeps moving, and yet somehow making it work. Egyptian obelisks and time you could trip over. So, you're in ancient Egypt. It's hot. Really hot. You're wearing linen. You smell like dust and incense. And all around you are these giant triangles and pillars that reach up toward the sky like the gods owe someone an explanation. And among all these epic structures, one invention quietly changes everything. The obelisk. A giant towering stone that looks like someone tried to build a skyscraper with only one floor. Tall, sharp, and absolutely unmissable. Now, to most people, obelisks just look like monuments, giant stone markers of power and glory. But to the ancient Egyptians, they were also clocks. Massive, deadly clocks. The kind of clocks that if they fell over, could flatten your cousin. Here's how it worked. Plant a tall object in the ground. Wait for the sun to rise. Watch the shadow stretch out like a sleepy cat. As the sun moves across the sky, the shadow moves too. It gets shorter, then longer again. It sweeps around the base like a very lazy sundial. And if you carve little markers into the ground where the shadow hits at certain times of the day, congratulations, you've invented timekeeping you can stub your toe on. The Egyptians were masters of this. They built obelisks, not just to honor the gods or show off their engineering skills, but to divide the day into pieces. They used the movement of shadows to create the earliest known method of splitting daylight into something like hours. Not perfect hours, but close enough for ancient bureaucracy. And let's be honest, ancient Egyptians loved their bureaucracy. They had calendars, they had schedules, they had tax deadlines, they even had worker strikes, which means somebody, somewhere, had to know what time it was. And you can't run a kingdom or a pyramid construction site on vibes alone, so they built stone time machines. Imagine being a temple priest. You wake up, grab your ceremonial eyeliner, and head to the obelisk to check how far the shadow has moved. Is it time to feed the sacred cats? sacrifice a chicken, start yelling at the workers again. The shadow knows. Now, here's where it gets more interesting and more mathematical. The Egyptians didn't just use obelisks. They created portable sundials too. Little L-shaped tools made of stone or wood. You stick it in the sun, look at where the shadow hits the markings, and boom, instant time. Like a pocket watch, but it only works when there's sunshine and you're facing the right direction. One of these devices, found in the Valley of the Kings, dates back to around 1500 BCE. That's over 3,000 years ago, and someone somewhere was using it to check if it was lunchtime. Now, to make a sundial like that work, you have to understand angles. You have to know how the sun moves across the sky at different times of year. You have to use math. It wasn't advanced calculus or anything, but it was geometry, observation, pattern recognition, all the same instincts we use today to program satellites, except they were doing it with string and shadows. And here's a fun twist. Egyptian hours weren't equal. That's right. Their daytime was always divided into 12 hours, and so was the night, but the length of those hours changed depending on the season. So in summer, the daytime hours were longer. In winter, they were shorter, which honestly makes a lot more sense than pretending all hours are equal when it's pitch black at 4 p.m. Imagine explaining that to your boss today. Sorry I'm late, Dave. It's winter, so I took a shorter hour. But the Egyptians didn't see time as rigid. They saw it as flowing, flexible, tied to the rhythms of nature and the gods. It wasn't mechanical yet. It was cosmic, alive, divine. They even had different gods for different times. Ra for the day, of course, but also Thoth, the god of wisdom and the moon, who helped keep time at night. You know, just in case you needed a celestial being to remind you when bedtime was. But while all this was happening, these majestic obelisks casting their shadows, priests measuring the march of Ra across the sky, something else was also happening. Math was quietly taking over time. The more humans tried to make sense of the day, the more we started carving it into chunks. First 2 parts, day and night. Then maybe 4 parts, morning, afternoon, evening, and oh no, it's dark. Then 12 parts. Then 20. And where did that number come from? Well, it wasn't entirely Egyptian, but we'll get to that in Babylon. That's another story. For now, just picture this. You're an ancient Egyptian, standing next to a massive obelisk. The sun is climbing. The shadow is shrinking. You're watching the sky and reading the ground. And somehow, without digital anything, you know exactly when it's time to go pray, or yell at your assistant for being late again. Because your entire schedule, your day, your sense of rhythm is now being dictated by light, shadow, and math. It's beautiful, really. Quiet, simple, elegant, and also slightly terrifying if you're standing too close when it tips over. These stone giants were some of humanity's first tools to measure the invisible. They didn't tick, they didn't glow, but they turned the chaos of sunlight into structure, and in doing so, they laid the foundation for everything that came after. So the next time you check the time on your phone, remember, it all started with a giant rock in the middle of the desert, chasing shadows, the Babylonian math that haunts us today. Let's talk about the number 6. You probably don't think about it very often. It just sort of sits there, quietly running your life. 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 360 degrees in a circle. It's everywhere. But have you ever stopped and wondered, why? Why not 10 minutes in an hour? Or 100? Why not something simple? Something friendly? Something that doesn't make your 3rd grade math homework feel like decoding ancient runes? Well, for that, you can thank the Babylonians. Let's rewind a bit. Ancient Babylon, around 4,000 years ago, located in what is now Iraq. Babylon was one of the great civilizations of the ancient world. They gave us writing, law codes, astronomy, and incredibly confusing math. Because the Babylonians used a base 60 number system, not base 10, not base 12, no, 6. And they didn't just use it, they loved it. They embraced it, married it, had little mathematical children with it. And thousands of years later, we're still living in the slightly weird, slightly brilliant math house they built. Now, to be fair, base 60 isn't as ridiculous as it sounds. It actually has some very nice features. For one, 60 is extremely divisible. You can divide it evenly by 2, 3, 4, 5 and 6. Even 10, 12, 15, 20, 30. It's a mathematical people pleaser. Try doing that with 10. Divide 10 by 3 and you get 333 free forever. That's not helpful. That's just anxiety with a decimal.
But divide 60 by 3. You get 20. Clean. Crisp. Elegant.
So, the Babylonians thought, why not build everything around this perfect harmonious number? And build they did. They created tables of multiplication, division, reciprocals, all in base 60. They used clay tablets to track astronomical events, property boundaries, and tax records. And they did it all in a system that basically turned every number into a kind of clock. The Babylonians didn't have 0, at least not in the way we do, which made things extra spicy. Imagine trying to do math without being allowed to write nothing. That's like trying to make a sandwich without using air. It's just bread, panic, and regret. And yet, somehow, it worked. They tracked planetary movements. They predicted eclipses. They laid the foundation for astronomy and accidentally made your microwave say 5,000 instead of 300 seconds. Their system stuck. Not because it was simple, but because it functioned. It fit well with early timekeeping. When people started measuring the arc of the sun across the sky, dividing it into 12 hours of daylight and 12 hours of night made sense. That's 24 total. Now divide each hour into 60 minutes. Then divide each minute into 60 seconds. Boom. Babylon just invaded your calendar. Again. And while most other number systems eventually moved on, Egypt had base 10, the Mayans had base 20, Babylon's base 60 stayed, like a weird roommate who never does the dishes, but still pays rent on time. To this day, we still use base 60 for time, and angles, and geographic coordinates. That's degrees, minutes, and seconds. Because of Babylon, a circle has 360 degrees. Why 360? Probably because it's close to the number of days in a year. And it divides nicely. It's also kind of satisfying. Full circle. Nice round number. But it's all built on that foundation of 60. Here's a fun fact. If you ever looked at a clock face and thought, why does this feel kind of ancient and mysterious? It's because it is. It's a visual representation of Babylonian math from thousands of years ago. Every time you glance at your wall clock, you're seeing a piece of Mesopotamian philosophy dressed up in modern hands and numbers. And no, they didn't have digital clocks back then. But if they did, you can bet it would have said 3:45 and not 2 and 2. Now, why does this matter? Because math is weirdly sticky. Once a system works, even if it's strange, even if it's hard to explain, people don't let go. Generations grow up learning it. Buildings get designed around it. Technology gets built to match it. And suddenly, it's permanent. So when you wonder why you're late for work at 8:03 a.m. instead of just saying I was late by 48 seconds, you can thank a bunch of ancient scribes sitting around a clay tablet going, you know what's sexy? 60. The Babylonians didn't mean to shape the way we live thousands of years later. They were just trying to count sheep or measure stairs or survive tax season. But their math system worked so well, so consistently, that it crawled its way through history, through empires, through religions, through industrial revolutions, and now it lives inside your phone. That's kind of amazing. The next time you're stuck in a meeting, staring at the clock, watching the minute hand crawl toward freedom, remember that you are participating in an ancient ritual. You, the digital clock, the number 60, all part of the same mathematical story. And that story started with people who looked up at the sky and thought, we should probably measure this. The Greeks invent philosophy, get distracted by time. Ancient Greece, land of olives, sandals, and an absolutely unnecessary amount of thinking. This is where philosophy was born. Logic, reason, the art of asking really big questions with absolutely no intention of finding a satisfying answer. Questions like, what is truth? What is beauty? Why do we stub our toes on furniture we bought ourselves? And of course, what is time? Because apparently, it wasn't enough to invent democracy and drama and triangles. The Greeks had to take one look at time and go, hold up, what is this thing really? Let's start with Plato. Plato, student of Socrates, teacher of Aristotle, eternal wearer of intellectual robes, gave us some of the earliest written ideas about time as a concept. He believed time was created by the gods as a moving image of eternity, which, let's be honest, sounds poetic, but also like something you say when you're stalling because your philosophy paper isn't done. In his dialogue, Timaeus, Plato described time as the imitation of the eternal. The perfect, changeless realm of forms gets copied into the material world, and boom, now we have time. Along with dust, traffic, and birthdays, to Plato, time wasn't real in the way that chairs or rocks are real. It was a product of motion, a measurement of change, like the universe was doing stuff, and time was just us keeping score. Now enter Aristotle, who said, cool idea, Plato, but what does that actually mean? Aristotle thought time was the number of change in respect to, before and after. That's not a punchline, that's a direct quote. Time was a measurement of movement. If nothing changed, time didn't pass. So basically, if you're sitting completely still, staring at the wall, and nothing around you moves or changes, congratulations, you've escaped time. Or you're in a very boring Zoom meeting. But the Greeks didn't stop there. They also invented paradoxes. Because what fun is time if you can't use it to break your own brain? Let's talk about Zeno. Zeno was a Greek philosopher who had a hobby. That hobby was annoying people with logic puzzles. His most famous one? Zeno's paradox of Achilles and the tortoise. Here's how it goes. Achilles, our Greek hero and part-time track star, is in a race with a tortoise. But the tortoise gets a head start. Now Achilles runs fast, much faster than a tortoise. But Zeno says, every time Achilles reaches the point where the tortoise was, the tortoise has moved a little bit forward. And when Achilles reaches that point, the tortoise has moved again, and again, and again. So technically Achilles never catches up, because there's always a little bit of distance left. Now, this is obviously wrong. You can beat a tortoise. You probably already have. But Zeno's point was to show how weird and slippery time and motion become when you slice them into infinite pieces. It's math versus common sense. Infinity versus intuition. And even though it feels like a trick, Zeno kind of had a point, because this paradox didn't just confuse his dinner guests. It later inspired actual mathematicians to develop calculus. Yes, calculus. All because some ancient Greek wanted to be annoying at parties. But here's the thing. For the Greeks, time wasn't just about measuring minutes or when lunch started. It was philosophical, existential, emotional. It was about change, permanence, the way the world never sits still. They even had two different words for time, chronos and kairos. Chronos is clock time, the tick-tock, the hours, the minutes, the relentless forward march of everything. That's the time your alarm clock screams at you in the morning. But Kairos is different. It means the right time, the perfect moment. The kind of time that isn't measured in seconds, but in feeling, like the exact moment to kiss someone, or the best time to tell a joke, or the weird cosmic click when something just feels right. The Greeks understood that time wasn't just mathematical, it was human, it was lived. And even though they didn't have quartz watches or smartphones or atomic clocks, they were already asking the same questions we still ask today. Why does time move forward? Why does it feel fast when we're happy and slow when we're bored? Is it real, or just something we invented to make sense of change? The Greek philosophers didn't solve time, but they did something just as important. They made it weird. They made it something you think about, instead of just experience. They took the everyday flow of existence and turned it into a puzzle. A philosophical, paradoxical, slightly maddening puzzle. And they passed that puzzle forward to scientists, to poets, to mathematicians, and now to us, sitting here in the future, trying to fall asleep to a YouTube video about clocks, because time hasn't gotten any less strange. We've just gotten better at pretending it's normal. Galileo drops things and reinvents the second. Okay, so clocks are ticking, bells are ringing. Monks are probably slightly less relaxed than they were before, but we still don't really have seconds. Not the kind you can count. Not the kind that tell you exactly how long you've been holding your breath or heating your leftovers. And then along comes Galileo Galilei. Yes, that Galileo. The guy who annoyed the church, stared at Jupiter, and basically invented modern science between snacks. But before he did all that, he was just a curious teenager, sitting in a cathedral, bored out of his mind. One day, while attending Mass, and possibly zoning out, young Galileo looked up and noticed something strange. There was a lamp hanging from the ceiling. A big, heavy, metal incense lamp, and it was swinging. Not wildly, just gently, back and forth, like a pendulum, because someone had bumped it. And most people would look at that and think, cool, moving lamp. But Galileo, he had what we call chronic observation disorder. So he kept watching, and he noticed something weird. Even though the arc of the swing was getting smaller because, physics, the timing of each swing stayed the same. Back and forth, back and forth. He didn't have a stopwatch. Those hadn't been invented yet. So what did he use to measure it? His pulse. Galileo literally took his own heartbeat and used it to time the swinging lamp. And what he realized was this. A pendulum, if left to swing freely, takes the same amount of time to complete each swing, no matter how wide or narrow the swing is, as long as it's small. This was a huge deal. It meant you could use a pendulum to measure time accurately and consistently, and that was something medieval clocks couldn't do. Not well, anyway. They were powered by falling weights and wild guessing. But pendulums could give you rhythm, precision, the steady heartbeat of a machine that didn't depend on moonlight or monk vibes. Years later, Galileo would write about this. He even started designing a pendulum clock, though he never finished it. But his idea caught on. A few decades after his death, people started building clocks based on his discovery, and suddenly time got sharper, tighter, tickier. But Galileo's obsession with motion didn't stop at lamps. He also loved dropping things, not because he was clumsy, but because he wanted to test gravity. There's a famous story, maybe true, maybe exaggerated, that he climbed to the top of the Leaning Tower of Pisa and dropped 2 balls of different weights to prove they fell at the same speed, because at the time people believed heavier objects fell faster, because they're heavier. But Galileo said no, that's not how gravity works, and he proved it. He showed that objects fall at the same rate, regardless of their mass, as long as air resistance doesn't mess things up, which again seems obvious now. But back then it was mind-blowing, and he used math to prove it. Equations, parabolas, tables of motion. Galileo basically turned the messy, unpredictable world of falling stuff into something you could chart, predict, graph. And once you can chart motion, you can measure time. Not just in vague stretches like morning or late afternoon, but in precise, countable seconds. Now, He didn't invent the second itself. That concept goes way back. The Babylonians had something like it. But Galileo gave us the means to actually measure it in real life, in real machines. His work laid the foundation for mechanical accuracy, not just in clocks, but in physics, astronomy, even music, because now we had tools, we had motion, we had measurement. And it all started with a bored teenager staring at a swinging lamp and thinking, that's interesting. It's such a beautifully human moment. No lab, no equipment, no budget, just eyes, curiosity, and a brain that refused to ignore a pattern when it saw one. Galileo's gift wasn't just that he observed things. It's that he trusted those observations. He took everyday moments and asked questions most people never would. Why does this swing the way it does? Why do objects fall like that? Can I use this motion to understand something bigger? And because of that, he changed how we think about the world and how we think about time. So the next time you see a lamp swaying, or a playground swing moving back and forth, or even just a metronome ticking away, think of Galileo. Think of how much we've built from something so simple. A swing, a heartbeat, a second. Newton tries to define time, and everyone gets a headache. Okay, so far, we've got sundials, obelisks, monks ringing bells, and Galileo dropping things for fun. Now it's time for someone to show up and make it all painfully complicated. Enter Sir Isaac Newton. You know the name. The apple guy. The gravity guy. The invented calculus because he was bored during a plague guy. Casual. Newton didn't just revolutionize physics. He tried to do the same with time. And when Newton tackled time, he did what Newton always did. He took a deep breath, opened a giant book, and tried to define it from scratch. Now, Newton wasn't messing around. He wasn't interested in how monks kept time, or how sundials worked, or how many minutes were in an hour. He wanted to understand what time actually is. And this is where things get spicy, because Newton believed in something called absolute time. To him, time was a kind of invisible river, always flowing, always ticking, everywhere, no matter what, even if nothing was moving, even if no one was there to see it. Time kept marching forward, relentless, unstoppable, kind of like your inbox. He said time wasn't dependent on events. It was its own thing, independent, existing beyond motion, beyond people, beyond planets. He literally wrote, absolute, true and mathematical time, of itself, and from its own nature, flows equably without relation to anything external. That's not just a sentence, that's a sentence with a monocle. But let's break it down. Newton is saying, look, time doesn't care about you. It doesn't care about stars or clocks or human schedules. It just is. It flows perfectly, constantly, like a cosmic stopwatch that never reset. And this idea worked really well for a while, because Newton's laws of motion were incredibly successful. They could predict the movement of planets, projectiles, pendulums, everything, all based on the assumption that there's a big invisible ruler of space and a big invisible clock of time, just sitting there being perfect. And honestly, that was comforting. It gave us structure, a way to map reality, to say, this happened at 3 Soren, and this happened 5 minutes later. Done. Thanks, Newton. But not everyone was sold. Some philosophers thought this whole absolute time thing was a bit extra. Like, how do you even prove time exists independently of events? If nothing changes, no movement, no motion, is time still passing? It's kind of like asking, if a tree falls in a forest and no one's around to hear it, does it still mess up your weekend? But Newton wasn't fazed. He had math on his side, and math in Newton's hands was practically a superpower. He laid out the laws of motion, the law of universal gravitation, and all of it rested on the idea that time ticks uniformly in the background like a silent, universal drumbeat. And for centuries, this view shaped how we saw the world, time became something external, something measurable, something that moved forward at a perfect rate, everywhere for everyone. This led to the rise of precision clocks, better pendulums, gears, springs, balance wheels, all trying to match the steady tick of Newtonian time. And with this new precision, we started scheduling trains, coordinating factories, and eventually synchronizing entire cities. Time was no longer a personal experience. It was a system, an infrastructure, a machine. But here's the twist. Newton's time, his beautiful, flowing, absolute time, wasn't actually real. Not completely. Anyway, because a couple centuries later, some guy named Einstein showed up, and he looked at Newton's time and said, "Yeah, about that, but we'll get to that. For now, let's take a moment to appreciate what Newton did accomplish. He made time measurable in a way it hadn't been before. He gave us the tools to build the industrial world, and he handed future scientists a framework they could either build on or completely destroy. Also, fun fact, Newton didn't just study physics. He was also super into alchemy, biblical prophecy, and trying to decode the apocalypse. Because apparently, even when you invent classical mechanics, you still need a few weird hobbies. So next time you check the time on your phone or wonder how fast something falls or think about the planets spinning in space, remember there's a little bit of Newton in all of it, and maybe a little headache too. Einstein murders. So Newton had a good run. He gave us gravity, motion, and the idea that time flows like a perfect invisible river, nice and smooth, always forward, always the same. And then along came a guy with messy hair, a quiet voice, and an absolutely diabolical relationship with reality. Albert Einstein. Einstein looked at time, Newton's beloved, steady, universal time, and said, "What if it's all relative?" And just like that, he murdered time. Metaphorically, of course. Time didn't fall over with a dramatic gasp, but Newton's concept of absolute time, that took a pretty big hit. Here's the deal. In 1905, Einstein published a little thing called the special theory of relativity. It sounds complicated. It is complicated. But at its core, it came down to this. Time is not the same for everyone.
Wait, what?
Let's break it down gently. You're lying on the couch, scrolling, relaxed. Time feels normal. You're not moving very fast, just a casual human velocity. But now, imagine someone else zooming past you in a spaceship at close to the speed of light. According to Einstein, that person experiences time more slowly than you do. Not because their clock is broken, but because motion actually changes the flow of time. This isn't science fiction, this is physics. It's called time dilation, and it's real. The faster you move, the slower time goes for you, relative to someone who's not moving as fast, which is absolutely wild. Because for centuries we thought time was a constant, something you could count on, something that ticked the same way for everyone. But nope, Einstein showed that time is like stretchy taffy. The faster you move, the more it stretches, the closer you get to the speed of light, the weirder it gets. And here's the kicker. He proved it with math. He didn't do an experiment. He didn't build a time machine. He just sat down and thought very, very hard, for years, in his free time, while working at a patent office. Seriously, this man reinvented physics on his lunch break. But wait, it gets weirder. In 1915, Einstein went even further with general relativity. He expanded his theory to include gravity. And what he discovered was this. Gravity doesn't just pull objects, it bends space and time. So massive objects like planets, stars, black holes, actually curve the fabric of space and time around them. Imagine laying a bowling ball on a trampoline. It makes a dent. Now imagine rolling a marble across the surface. It curves around the dent. That's gravity. And time? Time flows differently in those dents. This means that if you stand next to something very massive, like say a black hole, time literally slows down for you compared to someone farther away. In other words, where you are in the universe affects how fast time moves for you. And yes, this has been tested. Astronauts on the International Space Station experience slightly less time than people on Earth. Not enough to notice, but enough that scientists have to account for it in calculations. And it gets even better. Your GPS only works because of Einstein. Satellites orbiting Earth experience both time dilation from their speed and a shift in time due to gravity. If we didn't adjust for these effects, if we used Newton's idea of absolute time, your GPS would be off by kilometers every day. So yeah, Einstein might have killed Newton's version of time, but he gave us one that actually works. One that explains why the universe behaves the way it does. Why time isn't a constant. Why it bends, stretches and slows down depending on where you are and how fast you're moving. But he also gave us something kind of terrifying. The idea that time is not fixed. That we don't all live in the same now. That every person, every particle, every point in space is experiencing a slightly different version of time. Which sounds like a philosophical nightmare, but also kind of poetic. It means every moment is unique, not just emotionally, but physically. Every second you live is your own little patch of the universe's clock. Einstein showed us that time is flexible, fluid, less like a ticking metronome, more like a flowing, shifting river that changes depending on where you're standing. And honestly, that's kind of beautiful. So next time someone tells you time is just ticking away, you can smile and say, actually it's ticking at different rates depending on your velocity and gravitational field. Thank you very much. Time dilation, explained by a commuter train, and a cheeseburger. Okay, deep breath. We've talked about Einstein. We've talked about relativity. We've said that time is stretchy and weird. But let's be real. Most people hear time dilation and immediately check out. It sounds like something that happens to your genes when you put on a few holiday pounds. So let's break it down. Slowly. Simply. With no equations. And with the help of a commuter train. And maybe a cheeseburger. Here's the setup. Imagine two people. One is standing at a train station sipping a coffee, watching pigeons make questionable life choices. The other person is inside a train, moving past the station at near the speed of light, which is already suspicious, because no real commuter train goes that fast. But we're doing physics now, so just go with it. From the perspective of the person on the platform, time is moving normally. They take a sip, the clock ticks, the minute passes. But for the person on the fast-moving train, something strange is happening. Time is slowing down. Not in a poetic, this moment is eternal kind of way. Literally, physically. According to Einstein's special relativity, the faster you move through space, the slower you move through time. From someone else's perspective, this means that while one person experiences, say, 5 minutes on the platform, the person on the train experiences slightly less. This is time dilation. It's not just theory. We've actually measured this. We've flown super precise atomic clocks on airplanes, and when those clocks come back down to Earth, they're a few nanoseconds younger than their twins who stayed home. Tiny difference. Yes, but real and measurable. Now let's talk about the cheeseburger. Imagine you're holding one. It's warm, it's melty, it's everything you need emotionally. You raise the burger to your mouth, but just before you take a bite, your friend whizzes by on a motorcycle at nearly the speed of light. From your point of view, you take a normal bite. Delicious. Predictable. From their point of view, though, it looks like you're moving in slow motion. Your hand rises slowly. Your mouth opens slowly. That bite takes forever. Not because you're being dramatic, but because to your fast-moving friend, your entire timeline is stretched, and it works the other way too. If you could somehow watch your friend on the motorcycle, they'd seem to be moving faster, like they're cramming more action into less time, because from your perspective, their clock is ticking slower. Everyone's time is different. It depends on how fast they're moving and where they're moving. But, and here's the weird part, to each person, their own time feels completely normal. The person on the train doesn't feel anything strange. They don't feel stretched. Their heart still beats once per second. Their cheeseburger still gets cold at the usual disappointing speed. Because time dilation only shows up when you compare clocks between different perspectives. It's not like you feel slower, it's just that someone else watching you does. Which leads to one of the most famous and kind of tragic thought experiments in physics. The twin paradox. One twin stays on Earth. The other flies off into space at near light speed for a few years, then returns. Because of time dilation, the spacefaring twin ages less than the earthbound one. When they reunite, one twin is old. The other is still young. Cue emotional movie soundtrack. And a lot of uncomfortable family dinners. But again, this isn't just sci-fi. It's real physics. Not just a theory, but something we now have to account for in modern technology. Like GPS satellites, which orbit Earth at high speeds and slightly higher altitudes. That means both velocity and gravity affect their internal clocks. So scientists have to correct for time dilation every single day, or else your navigation app would be totally useless. You'd end up trying to drive to the grocery store and somehow arrive in a lake. Time dilation is small in everyday life, but it's always happening. Time is never flowing exactly the same for everyone. The person next to you, their clock is ticking just a little bit differently from yours. Not enough to notice, but enough that technically you're each living in your own personal version of the universe's timeline. It's not spooky, it's just how space-time works. Einstein didn't break time to mess with us. He just told us the truth. That time is a local experience. It changes based on speed. It changes based on gravity. It's not the same for everyone, and it never was. So, next time you're on a train, maybe not moving at light speed but still late for work, just remember, you're experiencing time in a slightly different way than the guy on the platform, and definitely in a different way than the guy microwaving fish in the office kitchen. That guy exists in a separate timeline of questionable decisions. The math behind a second. Let's talk about the second. Not a second like wait a second. I mean, the second. The official scientific, capital S second. The one that shows up on your watch, your phone, your microwave, your treadmill, and that countdown timer on the pizza oven you're watching way too closely. We all use seconds. We live by them. But have you ever stopped and wondered, what even is a second? Like, seriously, who decided what 1 second is? And how did they measure it before clock, or before batteries, or before atoms? Well, buckle in, because this is the story of how we define time so precisely that we had to start using lasers. Let's start simple. In ancient times, a second was just a vague idea. People divided the day into hours, then into minutes, and eventually into second, as in the second division of the hour, hence the name. That's literally why it's called a second. So great. But how long is it? For a while, the answer was 186/400 of a day. Why 8? Because that's how many seconds there are in 24 hours. Don't ask who first sat down and counted them. It was probably someone with 0 friends and access to a lot of sundials. But here's the problem. Earth doesn't spin perfectly. It wobbles. It drifts. It's got tectonic plates and weather and a moon tugging on its oceans like a needy toddler. So measuring a second based on the planet's rotation turned out to be not great. You want time to be precise. But Earth is more like close enough, I tried. So scientists decided to upgrade. They stopped using the Earth as a clock and started using something much cooler, atoms. In 1967, the scientific world officially redefined the second, no longer based on Earth's rotation. Now it would be based on something far more consistent, the vibrations of a cesium-33 atom. Yes, we now measure time with atoms. Here's how it works. Cesium atoms vibrate at a very specific frequency when you hit them with just the right amount of energy. And when I say very specific, I mean extremely specific. 1 second is defined as the duration of 9,001 to 2,000, 60, 31,000, 70, 70 periods of radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-33 atom. Say that 5 times fast. Or don't. You'll fall asleep immediately. But what that means is, we built clocks that literally count atomic vibrations. And once they hit that magic number, 9 billion and change, 1 second has passed. It sounds ridiculous, but it works, and it's accurate to something like a few billionths of a second per day. That's bananas. These are called atomic clocks, and they're the reason the world stays in sync. Air traffic control, internet networks, GPS, satellite systems, scientific experiments, international banking, they all rely on these clocks ticking perfectly, the exact same second everywhere. There are cesium clocks on the ground. There are atomic clocks in space. And if they ever disagreed, even slightly, your maps would be wrong, your data would be off, and your online shopping order might get sent to Jupiter. Okay, maybe not Jupiter, but like Nebraska. And you live in Sweden. Still bad. Now, cesium isn't the only atomic option. There are newer clocks using other atoms like rubidium or strontium that are even more accurate. There's even talk of optical lattice clocks which use lasers to trap atoms in a kind of light-based egg carton and then measure their quantum vibes. Because when regular timekeeping just isn't enough, you've got to start measuring the vibe frequency of the universe itself. But let's step back a second. Pun? Absolutely intended. Why go through all this trouble? Why build machines that count atomic wiggles and fire lasers into trapped clouds of gas, just to define a second? Because in our modern world, precision matters. 1 second of error in a satellite's clock could mean hundreds of meters off in GPS positioning. That's the difference between turn left now and you've driven into a lake, and in physics, even tinier fractions of time matter. Experiments at particle accelerators or observatories depend on measurements down to the nanosecond or smaller. So we chase perfect time. We build atomic temples. We count the dance of cesium. And we tell ourselves, this is 1 second. Not the feeling of a moment. Not the pause before a kiss. Not the endless stretch of a Monday meeting. Just 9,192,006 to 31,070 vibrations. Tick. Done. It's weird. It's abstract. It's kind of beautiful, because it shows just how far we'll go to make the invisible feel real, to measure the unmeasurable, to take something like time, a concept nobody truly understands, and nail it down with lasers, atoms, and math. The leap second crisis. So, we've defined the second. We've nailed it down with lasers. We've counted atomic wiggles. We've reached peak human precision. Everything should be perfect, right? Well, not quite. Because no matter how precise our clocks are, the Earth doesn't care. Remember earlier when we said Earth doesn't spin perfectly? Yeah, that turns out to be a huge problem. Our planet isn't a Swiss watch. It's more like an old washing machine. It rattles, it wobbles, and sometimes it just slows down. Tides, earthquakes, volcanic eruptions, atmospheric shifts, even melting glaciers. All of it messes with how fast Earth rotates. Sometimes it speeds up. Sometimes it drags. We're talking milliseconds here. But over time, those milliseconds add up. And if we let our atomic clocks keep ticking at their perfect pace while Earth takes its sweet geological time, eventually they drift apart. So the people in charge of timekeeping, and yes, there are people in charge of timekeeping, said, okay, fine, let's fix it. Their solution. Add a leap second. Just like we add a leap day every 4 years to fix the calendar, we sometimes add a leap second to fix the clock. It usually happens at the end of June or December. A clock will go from 23 to 20 and then to 0. Congratulations. You've just lived through a 61-second minute. Sounds harmless, right? Just one extra tick. But in the world of computers and global systems, that tick is pure chaos. Here's why. Most computer systems are not built to expect 60 seconds in a minute. They're built on a rigid, very smug assumption that a minute always has 60 0 to 59. No more. So when that leap second hits, all kinds of things can go wrong. Servers crash. Databases freak out. Stock trading systems throw errors. Airlines panic. And somewhere, some poor IT guy gets woken up at 2 a.m. and has to reboot something very expensive. In 2012, a leap second took down Reddit, Mozilla, LinkedIn, Airbnb, and Qantas Airlines. All because of 1 second. One. In 2015, another leap second caused glitches in Twitter and thousands of other systems around the world. Again, just 1 second. Just one extra tick. The issue isn't the length of time. It's that time is not supposed to surprise us. Computers are logical, predictable. They like routines. And the leap second is like someone whispering boo into a room full of sleeping robots. It's funny, but also kind of terrifying. So, people started asking, is this worth it? Do we really need to keep atomic time synced up with Earth's messy, moody rotation? Or should we just let them drift apart? I mean, Earth is slowing down by about 1.8 milliseconds per century. At that rate, it would take about 50,000 years to add an extra hour. So maybe we could just leave it alone. This debate has been going on for years. On one side, you have the astronomers, who are like, we must stay true to Earth. The heavens are our clock. Keep it natural. And on the other side, the tech people are like, please stop. Our servers can't take this. And so, the leap second has become this weird little battleground, a war fought between science, technology, and a planet that refuses to cooperate. In fact, in 2022, international timekeeping authorities voted to abolish the leap second. Not right away, but sometime after 2035, they plan to stop adding them altogether. They'll let atomic time and Earth time drift apart. Slowly and peacefully. No more surprise seconds. No more crashing websites. No more sleepless sysadmins. And honestly, it's kind of poetic. The leap second was our attempt to force perfection onto something inherently chaotic, to make the Earth act like a machine. But Earth isn't a machine. It's a spinning, bubbling, groaning, breathing ball of geology and weather, and wild unpredictability. And maybe, just maybe, we can let time be a little imperfect too. So next time someone tells you there's not enough time, remind them. Sometimes we add time, and it nearly breaks the internet. Entropy and the arrow that only points one way. Let's talk about why time only goes forward. You've probably noticed this. You wake up, you get older, your coffee gets cold, your toast never jumps back into the toaster to become bread again. Time, as far as we can tell, is a one-way street. No U-turns, no rewinds, no oops, let me try that again. But why? Why does time have a direction at all? Enter entropy, the universe's favourite excuse for chaos. Entropy is a fancy word from thermodynamics, which is basically the science of why everything eventually falls apart. Your ice cream melts, your bedroom gets messy, your socks go missing. That's entropy at work. In simple terms, entropy is a measure of disorder. The more disordered something is, the higher its entropy. Imagine you drop an egg on the floor. It shatters. Congratulations, you've just increased entropy. The egg went from an ordered state, egg, to a disordered state, sad mess. Now, technically, the laws of physics don't forbid the egg from unbreaking. In theory, all those pieces and molecules could magically fly back together to form a perfect egg again. But the probability of that happening is so small, you'd have to wait longer than the age of the universe to see it. And that's the arrow of time. Entropy always increases. Systems naturally go from order to disorder. That's why we can remember the past, but not the future. The past was lower entropy, fewer broken eggs. The future, more mess, more chaos, More entropy. Time's forward direction isn't something fundamental like gravity. It's more of a cosmic side effect of the universe being lazy. Everything's slowly spreading out, losing energy, and turning into what physicists lovingly call heat death. Cheerful, right? Don't worry, we'll get to that later. For now, just know that entropy is the reason why your ice cubes melt instead of unmelting, why coffee cools instead of heating itself up, why time, at least for us, has a direction. But here's the twist. At the tiniest scales, the laws of physics don't actually care about direction. If you zoom in far enough to particles, to quantum events, the equations work the same forward or backward. They don't know or care which way time is flowing. It's like a reversible movie. The math doesn't mind if you hit rewind. So where does the arrow come from? Why do we at a human level feel time moving forward? One big reason is entropy's love of probability. There are simply more ways for things to be messy than for things to be neat. Think of a deck of cards. There's only one perfectly ordered sequence, ace through king, in order. But there are millions of random shuffles. The universe is like that. The neat, ordered states, like your egg, are rare. The messy states, like your breakfast disaster, are everywhere. So naturally, as time passes, things move toward mess. It's not that the universe hates order. It's just that disorder is easier. And once disorder starts, it's almost impossible to reverse without dumping in a ton of energy. Now, here's the fun philosophical part. If time's direction is tied to entropy, does that mean that if entropy could run backwards, time would too? Would we remember the future instead of the past? Would we watch broken cups jump back onto tables, reheating tea mid-air? It's a bizarre thought, but some physicists actually think this could happen in theory, in regions of the universe where entropy decreases. Not that we've ever seen that.
But still, spooky.
For us, though, entropy rules everything. We live in a high entropy world. Our memories, our experiences, our arrow of time, they all come from the way energy spreads and chaos grows. Even life itself is a little rebellion against entropy. We're these fragile, temporary arrangements of atoms, desperately trying to hold off disorder. But even we don't win forever. Eventually, we crumble back into chaos, just like everything else. Which sounds sad, but actually it's kind of comforting, because it means every moment, every little ordered, beautiful moment is rare. It's special. It's a temporary pause in the infinite noise, and that's worth something. So next time your coffee gets cold, or your ice cream melts, or your egg refuses to unbreak, don't get mad. Just remember, that's time doing its thing. Entropy, gently nudging the universe forward, one messy second at a time. Calendars are just social experiments. So, we've talked about seconds, we've talked about entropy, we've talked about time bending and stretching and refusing to let eggs unbreak. But now let's talk about something even stranger, even more chaotic, even more broken than the laws of physics. Let's talk about calendars. Because if you thought time was weird, wait until you see what humans did to organize it. Calendars are basically a giant social experiment that got wildly out of hand. They were supposed to help. They were supposed to keep track of harvests and festivals and when not to eat fish. Instead, they turned into a historical mess of emperors, popes, politics, and passive-aggressive months, with the wrong number of days. Let's go back to the beginning. Ancient civilizations didn't have clocks, but they had the sky. And the sky, while mysterious, is at least consistent. The sun rises and sets. The moon waxes and wanes. The stars shift with the seasons. So early humans tracked these patterns. They counted days between full moons. They watched the length of shadows. They built giant rock circles and said, okay, that's probably the solstice. Time to have a ceremony. Maybe sacrifice something. Some calendars followed the moon, like the Islamic calendar. Some followed the sun, like the Egyptian one. Some tried to do both, like the Hebrew and Chinese calendars, and instantly regretted it because that's when math gets spicy. Then came the Romans. The Romans loved order. They also loved power. And they really loved naming things after themselves. So, naturally, they decided to fix the calendar. At first, the Roman calendar was a hot mess. It had 10 months, then 12, then back to 10. Some months had 30 days, some had 31. One had like 3 goats and a shrug. They even used random extra months just to reset things when they got too off track.
That's right. Bonus months.
Imagine waking up and learning it's suddenly 2nd November. That actually happened. Finally, in 46 BCE, Julius Caesar stepped in. He introduced the Julian calendar based on the solar year, 12 months. Every 4 years, add a leap day. Nice, clean, logical, but not perfect. Because the actual solar year isn't 365 days, it's about 3060. So every year, the Julian calendar was off by about 11 minutes, which doesn't sound like a lot until you let it pile up for a few centuries. Fast forward to the 1500s, the calendar is now off by 10 whole days. Easter is drifting into summer. Church holidays are out of sync. Farmers are planting based on the wrong stars. It's time for another fix. Enter Pope Gregory the... Gregory didn't like math. He liked Easter. So he called in the astronomers and said, fix it, and make Easter normal again. They did. In 1582, the Gregorian calendar was born. To fix the drift, they skipped 10 days. October 4th was followed by October 15th. People were very confused. Some thought they'd been robbed of a week of their lives. Some protested in the streets. Some probably just used it as an excuse to avoid paying rent. But it worked. They also adjusted the leap year rule. Now every 4 years is a leap year, unless the year is divisible by 100, unless it's also divisible by 400. So the year 1600, leap year.
The year 1700. Nope.
The year 2000, the year 2100. Sorry, no extra day for you. Why so complicated? Because precision. We wanted our calendar to match the Earth's orbit as closely as possible. So we built a system that was mathematically elegant and emotionally exhausting, but not everyone jumped on board. Protestant Europe didn't trust the Pope, so they kept using the old calendar for a while. Britain didn't switch until 1752, by which point the calendar was now 11 days off. So they skipped from September 2nd to September 14th. Again, mass confusion. Again, people yelling, give us back our days. Russia didn't switch until Greece held out until... So for centuries, depending on where you lived, it could literally be a different day than the country next door. Imagine scheduling a meeting. Let's meet on April 12th. Which one? But despite all this chaos, the Gregorian calendar eventually won. Today, it's used in most of the world, not because it's perfect, but because it's good enough. Even though the months don't make sense. Why does February have because of some Roman emperor drama? Why September, October, November and December named after 7, 8, 9 and 10, even though they're the 9th, 10th, 11th and 12th month? Because Julius Caesar and Augustus each wanted their own months. July and August, and they stole them from the front of the year. Petty calendar politics. Classic Rome. So here we are, living in a system that started as a lunar cycle, got reshaped by emperors, fine-tuned by popes, and is now held together by computers, leap years, and sheer cultural momentum. Calendars aren't scientific, they're stories. Stories we tell ourselves to make sense of the sky, of the seasons, of birthdays and taxes and pumpkin spice lattes. They're just agreements. Beautiful, messy, global agreements. So next time you look at the date, just remember, it's not absolute, it's not cosmic, it's just a tradition. A very well-organized guess. Why Tuesdays don't exist? Let's start with a simple question. What day is it? You probably have an answer. It might be Tuesday. It might be Friday. It might be that weird blur between Sunday night and Monday morning when nothing feels real anymore. But here's the twist. Days of the week aren't real. I mean, they exist. On your phone, on your calendar, in your brain. But But in the grand cosmic sense, there's no such thing as Tuesday. No physical thing changed in the universe when it became Tuesday. The planets didn't rearrange. The atoms didn't cheer. The laws of physics didn't notice. Tuesday is just a word, a label, a mental post-it note stuck to a spinning rock. Let's rewind. The 7-day week is a completely human invention. It doesn't line up with the solar year. It doesn't match the moon. It's not based on tides or eclipses or star positions. It's just something we made up, and then decided to take very, very seriously. Why 7 days? Well, blame the Babylonians again. They liked the number 7 a lot. They observed 7 celestial bodies with the naked eye: the sun, the moon, Mercury, Venus, Mars, Jupiter, and Saturn. So they figured, hey, let's make a week out of that. They assigned each day to one of those heavenly objects: Sunday for the sun, Monday for the moon, Saturday for Saturn. The rest got passed around like leftovers in a cosmic potluck. Then the Romans picked it up, then Christianity, then Islam, then everybody, more or less, and boom, 7-day week, global standard, totally made up, but powerful, because over time we built our entire emotional rhythm around it.
Monday, the worst.
Tuesday, slightly less bad. Wednesday, hope. Thursday, hang in there. Friday, the promised land. Saturday, glory. Sunday, existential dread. None of these feelings are tied to actual physics. They're calendar psychology. Now imagine explaining this to an alien. Hello, welcome to Earth. We divide our time into groups of 7. Each one has a name and a unique emotional profile. Tuesday is for low-level anxiety. Thursday is for optimism with a hint of exhaustion. The alien would probably just turn around and leave. But that's what we do. We make meaning. We take a spinning planet and break it into days and weeks and routines, so we can feel like we're making progress. And honestly, that's kind of beautiful, but also very, very weird. Let's dig deeper. Each day has its own identity. Not because the universe gave it one, but because we did. We assign meaning. We say, let's meet next Thursday. But what is Thursday? It's just the Earth doing a quarter turn. That's it. One more slow spin on an axis tilted at 23.5 degrees. If you didn't know it was Thursday, it would feel like any other day. There's no Thursday particle floating in the air. No subatomic weekon that tells you what day it is. It's all in your head and your calendar app. Even the way we name the days varies across cultures. In English, the days are named after Norse and Roman gods. Thursday is Thor's Day. Wednesday is Wednesday. Friday? That's for Frigg, Odin's wife and goddess of possibly comfort snacks and bubble baths. In many Romance languages, days are named after planets. Lunes for Monday, Martes for Mars, Miércoles for Mercury. It's all mythology, astronomy, and linguistics rolled into one big existential burrito. But the real kicker is this. Because the 7-day week doesn't line up with the year, it drifts. If you live long enough, your birthday will fall on every day of the week at least once. That means that even the rhythm of your life is spinning around in a wobbly loop of artificial structure. So when we say, I hate Mondays, what we really mean is I've emotionally assigned dread to a particular segment of a repeating pattern that doesn't exist in the laws of nature. Which is kind of hilarious, and also a little freeing, because if the days of the week are fake, you're allowed to feel however you want, whenever you want. You don't have to wait until Friday to be happy. You don't have to hate Tuesday just because society told you to. The universe doesn't care what day it is. But you get to. And if you want to make up your own system, a 5-day week or a 10-day month or a nap day between Wednesday and Thursday, who's stopping you? You wouldn't be any less accurate than the Romans. In fact, the only reason the 7-day week stuck is because we kept agreeing it was real. It's a collective illusion, but it's a useful one, because even if Tuesdays don't exist in a cosmic sense, they matter in a human one. They're how we share time, plan birthdays, dread meetings, watch new episodes, count down to pizza night. They're our rhythm, our social heartbeat, our way of saying we're all spinning through this together. So next time you wake up on a random weekday and groan, just remember, there is no Tuesday, only you, and the sky, and your weird, wonderful little calendar. Time is different on the moon, and that's a problem. Let's say you're on the moon. First of all, congratulations, great views, no lines, absolutely terrible Wi-Fi. But here's something nobody tells you. Time is weird up there. Like, officially, objectively, physically. Time actually ticks at a different rate on the moon than it does on Earth. Not metaphorically, not emotionally, literally. And that's a bit of a problem. Because if we're serious about space travel, if we're going to build moon bases, lunar labs, maybe even moon coffee shops, we need to figure out what time it is up there. And right now, nobody agrees. Let's break it down. We've talked about how time is affected by gravity and motion. Thanks to Einstein, we know that time runs a little slower when you're in a stronger gravitational field, which means time moves faster the farther you are from a massive object like Earth. The moon has less gravity than Earth, so time on the moon ticks just a little faster. Not by much, just about 56 microseconds per day. That's 56 millionths of a second. You wouldn't notice it. Your coffee would still get cold at the usual speed. Your Zoom calls would still feel endless. But for science, for navigation, for anything involving computers, communication or satellites, that matters a lot. Because when time drifts, even a little, it can mess everything up. Coordinates get scrambled. Signals go out of sync. Systems crash. And that's the last thing you want when you're operating a lunar forklift 400,000 kilometers from the nearest tech support. So what's the solution? Right now, there isn't one. We still use Earth time for everything, even on the moon. When astronauts went to the moon during the Apollo missions, they used something called mission elapsed time. Basically, a stopwatch that started the moment they launched. No time zones, no Greenwich Mean Time, just the mission clock. But as we plan for long-term lunar missions, that's not going to cut it. We need a standard lunar time, a time zone for the moon. And that's where the arguing starts. Because whose time do we use? Do we base it on Earth time, and if so, which country? Do we create a brand new moon time, sync to lunar days and nights, which by the way are each about 14 Earth days long, so forget your 9-to-5 schedule. Do we let every nation, every agency, every private space company invent their own moon time? Great idea if you enjoy confusion, chaos and possibly interplanetary lawsuits. Recently, the European Space Agency said, "Hey, maybe we should all agree on this before someone sets up a moon office and starts missing calendar invites." NASA agreed, so did a bunch of other space nerds. But as of now, it's still being debated, because defining time, even just on Earth, has always been more political than scientific. Calendars, time zones, daylight saving, it's all negotiation and compromise. And now we're trying to do it in space. Let's think ahead. Imagine a future moon base. It has astronauts, scientists, engineers, maybe even tourists. They wake up, go to work, eat lunch, make repairs, take moon selfies. What time is it? Is it Moon Standard Time? Is it Earth UTC? Is it Mission Time, Houston Time, or Lunar Local Time, based on where the sun rises over a particular crater? Now imagine two moon bases, one run by NASA, one run by another space agency. They try to coordinate a meeting. One thinks it's Tuesday at 3 p.m. The other thinks it's Sol 5 at Phase 2 of Cycle O. They both log into the same Zoom call and nobody shows up, because time, once again, has become imaginary. It's funny, isn't it? We've spent centuries trying to define time on Earth. Atomic clocks, calendars, GPS satellites. And now, just as we think we've got it figured out, the moon shows up and says, "Not quite." And this is just the moon. Imagine when we get to Mars, where the day or sol is 24 hours and 39 minutes. You think daylight saving time is annoying. Try explaining why every week on Mars is slightly off. We're going to need new clocks, new standards.
New agreements.
Not just for Earth, but for space. Because the farther we go, the more time stops being something we share and starts becoming something we negotiate. Time, once again, reveals itself to be a story we're telling, a system we're building, a language we're still learning to speak, even as we leave the planet that taught it to us. So the next time someone says, "I don't have time," just smile and think of the moon, where time moves faster, where clocks don't quite match, and where someday someone will have to figure out when lunch is. On a planet that never asked what noon means, black holes eat time for breakfast. We've talked about time bending. We've talked about time speeding up and slowing down. We've talked about time being made up by humans with very strong opinions about Tuesdays. But now we're going to the edge of physics, the edge of space, the edge of time itself. Let's talk about black holes, the places in the universe where time goes to die. Okay, that's dramatic, but also not entirely wrong. So what is a black hole? In simple terms, it's what happens when a lot of mass gets crammed into a tiny space. So much mass that gravity goes bananas. It collapses in on itself and creates a region so dense, so powerful, that not even light can escape. Hence the name, black hole. But here's the fun part, or the terrifying part, depending on your mood. Black holes don't just mess with space, they mess with time. Let's imagine a scenario. You're in a spaceship. You're curious. You've had your coffee, and you decide to fly very close to a black hole. Not into it, because that's a one-way trip. Just close enough to feel its gravity. From your point of view, everything feels fine. Your clock ticks normally. Your Spotify playlist is still playing. Your snack bar is still disappointing. But to someone watching you from a safe distance, say floating far away in their own very judgmental spaceship, it looks like your time has slowed down, dramatically. This is called gravitational time dilation, and it's just like what we talked about with the moon, but on steroids. The closer you are to a massive object, the slower time moves for you, compared to someone farther away. Near a black hole, that effect is extreme. You could orbit a black hole for an hour, and when you return to your friend out in space, they've aged years. No joke. This is actual physics. It's the plot of Interstellar, and it's real. In fact, scientists have calculated that near the edge of a black hole, what we call the event horizon, time slows down so much that from the outside it almost stops.
You fall in.
And to everyone watching, you freeze. They'd see you getting closer, slower, until you just hover at the edge of the event horizon forever. You, on the other hand, would keep going, falling through the event horizon, into the unknown, in what feels like a completely normal pace for you. But for the rest of the universe, you're gone. Not just in space, but in time. So yeah, black holes don't just eat light, they eat causality. And the weirdness doesn't stop there. Some physicists think that the center of a black hole, the singularity, is where space and time collapse into each other, where the normal rules break down, where we don't know what happens because the math just kind of gives up. It's like the universe's version of does not compute. And that's the thing about black holes. They're not just places. They're tests. Tests of gravity. Tests of space. Tests of time. They're the ultimate what-if scenario. What if gravity was so strong that time stopped making sense? And here's the craziest part. Black holes are real. We've found them. We've photographed them. There's one at the center of our galaxy, the Milky Way, just hanging out, slowly devouring things, while time crawls at a different pace around it. There are probably millions of them out there, just spinning, bending light, distorting time, like cosmic pranksters. But don't worry, the nearest one is very far away. You're not going to fall into one by accident while going to IKEA. So, what do black holes teach us? They teach us that time isn't absolute, that it bends, stretches, and warps in ways we can't feel, but can absolutely measure. They show us that clocks, even atomic clocks, don't tick the same everywhere, and that the universe is much weirder than we like to believe. They also remind us that no matter how much we think we understand, there are places we can't yet reach, questions we can't yet answer, edges we haven't yet crossed. And maybe, just maybe, time itself is one of those edges. Because if black holes can freeze time, what else can? Could we someday control time? Pause it? Loop it? Travel through it? Physicists argue about that stuff all the time. But black holes are where the debate gets serious. Because when you stare into a black hole, it doesn't just stare back, it bends back. The heat death of the universe, and the end of time, in your signature soft, slow, and slightly haunting bedtime tone. Word count 180. Ready for 11 Labs narration. Chapter 18. The heat death of the universe, and the end of time. So, we've made it a long way. From cave shadows to atomic clocks, from swinging lamps to black holes, from ancient guesses to cosmic precision. But now, let's talk about the end. Not just the end of this video, not the end of a century, not even the end of Earth. Let's talk about the end of time itself. It sounds dramatic, and it kind of is, but scientists have a name for it. A calm, quiet, almost polite name. It's called the heat death of the universe. And no, it's not when you leave your laptop on your legs for too long. It's the theoretical future when everything stops happening. Let me explain. The universe, as we know, is expanding. Galaxies are moving away from each other. Space is stretching. It's not slowing down. It's speeding up. Over time, stars will burn out. Black holes will evaporate. Matter will break down into smaller and smaller particles. And everything will spread out, colder and colder, farther and farther. Until one day, there's nothing left to do. No energy gradients, no heat differences, no usable energy, just stillness, no more structure, no more movement, no more time. Because here's the thing, time needs change. We only notice time because things change. The sun rises, people grow older, atoms vibrate, particles interact, but in the far future, in the cold, empty vastness, none of that will be happening. No clocks ticking, no light travelling, no particles bumping into each other. Just a uniform, silent universe. No before, no after, no time. This is what physicists mean by heat death. Not fire, not explosions, but the total end of difference. Everything is balanced. Everything is flat. Everything is done. It's the ultimate entropy, maximum disorder, but also in a strange way, maximum peace. Now, will this actually happen? We don't know. It's one theory, the good one, but there are others. Some think the universe might crunch back in on itself one day. Others think new universes might bud off like cosmic mushrooms. Others think we'll hit a quantum weirdness point and reboot the whole thing. But if the current math holds, then heat death is the most likely fate, and it won't happen tomorrow, or in a million years. We're talking trillions upon trillions of years from now, so there's still time to enjoy your coffee, still time to text back, still time to binge all those shows you've been putting off. But still, the idea is powerful, that time could just stop, not because it runs out, but because there's nothing left for it to measure. No events, no clocks, no moments to move between. Just a universe at absolute rest. And you might wonder, if time ends, does that mean existence ends? Maybe. Or maybe time is just one layer of reality, a thing our minds built to make sense of movement, and when there's no movement left, the concept quietly dissolves. Like mist, or memory, or a really good dream right before waking up. And here's the most human part of all this. We know we'll never see it. No one will. There will be no one around to witness the end of time. No last moment, no grand finale, no curtain call, just a long, slow fade. But somehow, we figured out how to predict it. With math,
With physics.
with little clocks and big questions. Tiny humans on a little planet counting seconds while the stars drift apart. It's oddly poetic. And maybe that's the real point. Not to fear the end, but to appreciate how astonishing it is that we can even imagine it. To think, to wonder, to calculate, all in a tiny window of cosmic time, a brief flicker before everything goes quiet. So if you're still awake, take a moment to be still. Feel the breath, the beat, the seconds passing. You are part of the story of time, a small chapter, but an important one. Clocks lie, your brain lies more. We've spent a lot of time, pun fully intended, talking about clocks, atomic clocks, pendulum clocks, digital clocks, clocks in space, clocks near black holes, clocks that count the vibrations of tiny atoms with spooky precision. But now we turn to the most familiar and most unreliable clock of all, the human brain. Because here's a secret, clocks lie. But your brain, it lies even more. Let's start with something simple. Have you ever noticed how 5 minutes can feel completely different depending on what you're doing? 5 minutes waiting in line? Eternity. 5 minutes talking to someone you love? Gone in a blink. Same amount of time, totally different experience. Why? Because your brain doesn't actually measure time like a stopwatch. It estimates. It guesses. It fills in the blanks. And it's influenced by everything. Mood, attention, temperature, music, hunger, caffeine, the phase of the moon. Probably. We don't just sense time, we construct it. There's an entire network in your brain dedicated to this. Your suprachiasmatic nucleus, which is real and not a Harry Potter spell, sits in your hypothalamus and acts as your master clock. It controls your circadian rhythm, your natural 24-hour cycle. This internal rhythm affects when you feel awake, tired, hungry, alert, sad, weirdly nostalgic, or suspicious of yogurt. But here's the fun part. It's not perfectly 24 hours. It's actually closer to 20. So your brain is always subtly adjusting, syncing itself to sunlight, social cues, alarm clocks, and the distant screams of Monday mornings. Without these cues, your rhythm drifts. Scientists have studied people in caves. Yes, that's a real experiment. And found that in total darkness with no clocks, no sun, and no Instagram notifications, people naturally shift into their own personal timelines. Some go longer, some go shorter, some become completely nocturnal. Some invent time from scratch, because when the outside world disappears, your brain just makes it up. Even in normal life, your internal clock is full of surprises. For example, when you're focused, time flies. When you're bored, time stretches. When you're afraid, time slows down, or at least it feels like it does. People who've been in accidents often say time seemed to move in slow motion. That's not because their perception changed in the moment. It's because their brain recorded the event in extra detail, and later when replaying it, it feels longer. Memory tricks time. Emotion stretches time. Attention speeds it up or slows it down. Your sense of time isn't a clock. It's a story your brain is telling you in real time. Even age changes how we feel time. When you're a kid, a year feels massive. Summer lasts forever. Waiting for your birthday is like climbing Everest in slow motion. But as you get older, a year starts to feel smaller, faster. Again. Like a blink. One theory. Each year is a smaller percentage of your total life. To a 5-year-old, a year is 20% of everything they've ever known. To a 50-year-old, just another theory. Routines compress time. The more sameness you experience, the less your brain marks those memories as distinct. And your memory, not the clock, becomes your measure of how long that felt. So if you want time to feel slower, try new things. Travel, explore, do weird stuff, create fresh memories. Because novelty slows down perception. Now let's talk about the weirdest hour of the day. 3 a.m., the hour of strange thoughts. The hour when you remember that thing you said in 20. The hour when the brain gets a little. Your internal clock dips lowest between 2 and 4 a.m. Body temperature drops. Alertness tanks. Emotions rise. Logic takes a nap. That's why 3 a.m. is when people text their exes, write their wildest poetry, or Google how to become a lighthouse keeper. Your brain is drifting. Your sense of time is fuzzy. Everything feels a little more dramatic, and yet somehow magical. Because time at 3 a.m. becomes more emotional than mechanical. It's not about hours and minutes. It's about memories, longing, wonder, imagination. It's soft time, dreamy time, the kind of time you don't measure. You feel. So yes, clocks lie. They tick with the cold, mechanical certainty of quartz and code. But your brain? Your brain tells time in stories, moments, feelings, rhythms. It builds a timeline from scraps of memory and emotional weight. It compresses a decade into a flash. It stretches a second into forever. It turns time from math into meaning. And, honestly, that's kind of amazing. Time is a flat circle, except when it's a spiral. By now you've probably gotten used to the idea of time as a line. Tick-tock, cause, then effect, past, present, future. A neat little timeline. Forward only. One long, straight road. No U-turns. No exits. But here's the thing. Not everyone sees it that way. In fact, depending on your culture, your philosophy, your religion, or your level of sleep deprivation, time might look very, very different. So let's get a little weird and take a dreamy detour through all the ways humans have imagined time. Let's start with the phrase, time is a flat circle, popularized by a very broody detective in True Detective who was definitely not okay, but the idea is much older. It shows up in ancient philosophy, especially in Hinduism and Buddhism, where time isn't a line but a cycle. Birth, death, rebirth. Over and over. Everything you do now, you might do again, in a different life, a different form, a different body. Time repeats. In Mayan cosmology, time was made up of repeating cycles called baktuns, massive, cosmic loops. When one ends, another begins. It's not about finality, it's about return. The Greeks had two different ideas of time. We talked about this earlier. Chronos, linear, measurable time. And kairos, the right moment, the sacred time, the emotional now. But they also flirted with cyclical time, the idea that history repeats, empires rise and fall in loops, and the universe refreshes itself like some kind of cosmic screensaver. In Nietzsche's philosophy there's the idea of eternal recurrence, that time loops endlessly. That every moment you're living, you've lived before, and will live again, forever, which is either terrifying or incredibly comforting, depending on how your day's been. But what about physics? Well, even there the idea of looping time shows up. Some cosmological models suggest that the universe might one day collapse back into itself, a big crunch, followed by another big bang. Boom. Reset. Time begins again. Others imagine time as a looping dimension, curled in on itself like a cosmic pretzel. The math doesn't forbid it. It just gives physicists migraines. Then there's the idea that time isn't just a flat circle, but a spiral. Think about a spiral. It loops, but it also moves forward. That's a compelling metaphor. Because life does feel cyclical. Seasons repeat, birthdays come back, your inbox never stops. But we also change. We grow. We're not in the same place, even if it looks familiar. A spiral says, yes, this moment looks like the last one, but you're not the same. You're one loop higher, one level deeper.
It's the rhythm of music, the growth of plants, the orbit of planets, the pattern of galaxies, even the structure of DNA, the literal code of life, is a double helix, a spiral. So maybe time isn't flat. Maybe it's not even round. Maybe it's a spiral staircase we're climbing in the dark, passing the same windows again and again, but from a new height. This makes room for memory, for learning, for déjà vu. It says, you've been here before, but you're not who you were. Time as a spiral feels honest. It honors the loops, but also the direction. Now, to really twist your brain, there are cultures that don't even think of time as going forward. In the Aymara language spoken in parts of the Andes, the word for past is in front of you, because it's what you can see, and the word for future is behind you, because it's unknown, unseen. That's wild, and also makes a weird amount of sense. It's a reminder that time is as much a perspective as it is a measurement. We don't just live in time, we interpret it, shape it, spin it into stories. Time is linear when we're working, cyclical when we're gardening, spiral when we're growing, frozen when we're waiting, endless when we're missing someone. So is time a flat circle, a spiral staircase, a stretched out rubber band, an illusion made up by monkeys with calendars? Yes, all of it. None of it? Whatever works for you. Because at the end of the day, or the loop, time is just a framework. A beautiful, bendy, inconsistent framework we've built to understand change, and sometimes to survive it. So, what is time actually? We've gone a long way together, from ancient shadows to atomic vibrations, from sundials to satellites, from the Big Bang to the far frozen future, and we've asked a lot of questions. Why do we count seconds? Why do some feel longer than others? Why does time bend, stretch, loop, speed up, slow down, or seem to disappear entirely? But now we've arrived at the biggest, softest, most impossible question of all. What is time, actually? And the honest answer is, we still don't know. We know how to measure it. We know how it behaves, most of the time. We know how to schedule lunch and miss meetings and feel nostalgic for things that happened decades ago. But the true nature of time, still slippery. Some scientists think time is real, a fundamental ingredient of the universe, like mass, or energy, or sarcasm. Others think time is an illusion, a side effect of how our brains process change, a useful construct but not something that exists on its own. In physics, space and time are merged into one four-dimensional thing called space-time, which sounds cool, but also sounds like something invented at 2 a.m. by someone with too many chalkboards. And in that model, time is just a coordinate, like height or width. You move through it, you don't feel it. It just is. But that doesn't match how we live. Because we do feel time, we feel it pass. We feel it stretch when we're anxious, rush when we're happy, creep when we're waiting, evaporate when we're in love. We remember the past. We imagine the future. We build our whole sense of self on this moving line between before and after. So maybe the question isn't what is time? Maybe the question is, why does it feel the way it does? Maybe time is real. Maybe it's not. Maybe it's just how we make sense of change. After all, without change we wouldn't need time. If nothing moved, nothing aged, nothing ever happened, why would we need clocks? Time is how we narrate change. It's the language of transformation. A before, a middle, and an after. Even in storytelling, like this, we use time as the framework. You start here, you end there, something happens in between. But time isn't just a story. It's also a feeling. It's the way a summer afternoon glows longer than it should. It's the way old songs teleport us to younger versions of ourselves. It's the way we count birthdays, the way we mark anniversaries, the way we measure missing someone. Time is structure. Time is mystery. Time is math.
and mood. And despite all our clocks and calendars and countdowns, time still finds ways to surprise us. Like how a memory can make years disappear, or how one conversation can feel like it lasts forever, in the best way, or how a single moment, just a look or a word or a realization, can stretch wide enough to change everything. So what is time? It's a heartbeat, a story, a rhythm, a trick, a teacher, a force, a friend, a mystery we're all moving through together. It's not always fair, it's not always kind, but sometimes it gives us exactly what we need, a moment of clarity, a little more patience, a reason to let go, or hold on, or try again. And maybe that's enough. Maybe we don't need to understand time, maybe we just need to be in it, right now, just for this moment, because now is the only time that's ever really real. Good night, and please don't try to build a time machine. Well, here we are, after 2 hours of ticking seconds, ancient clocks, relativity, lunar confusion, black holes, spirals, and sleepy existential dread. You've made it, or at least some version of you has, because time, as we now know, is weird like that. Maybe you're still awake. Maybe you drifted off somewhere around chapter 9 during the part about Einstein and cheeseburgers. That's okay. This story was never about racing to the end. It was about being inside it, letting time pass gently, like water through fingers. But before we say goodbye, let's just ask one last silly little question. Should you build a time machine? And the answer is no, please don't. It sounds fun. It sounds exciting. But have you ever seen a single movie where that went well? No, you haven't. Time machines always lead to paradoxes. You save your grandfather and erase your own existence. You step on a butterfly and create a world run by sentient staplers. You bring back fire to the past and get chased by cavemen holding Excel spreadsheets. It never ends well. Besides, physics is not on your side. Most scientists agree time travel to the past is likely impossible unless you've got some wormholes, dark energy, and a very relaxed interpretation of causality. And if time loops were real, we'd probably know. Someone would have shown up by now, in a weird hat, with a glowing watch, speaking in riddles, unless they already did, and we missed it, because we were too busy scrolling. Anyway, let's not worry about building machines, because the truth is, you already are one. Your brain, your memory, your attention. You are a time traveler, moving 1 second per second, from moment to moment, forward, always forward, through a story no one else has ever lived. And that's kind of beautiful. You've got everything you need. You can revisit the past with memory. You can explore the future with imagination. You can stretch a moment with presence. You can escape a minute with laughter. And you can fall asleep right now and let time pause just for a while, because that's the secret. Time feels sharp when we fight it, but it softens when we surrender. When we say, yes, okay, I'll drift with you for a bit. And maybe, just maybe, that's why you're here. Not to conquer time, not to master it, but to notice it, to ride its waves, to enjoy its strangeness, to laugh at its rules, to share your tiny window of existence with the rest of us. So here's a final thought. No matter what the clocks say, you are right on time. Not early, not late, not behind schedule, not too old, not too young, not running out. You're here, now, alive in a moment the universe will never repeat. And if that's not magic, I don't know what is. So go ahead, rest, close your eyes. Let time take over. Let the clocks keep ticking. Let the earth keep spinning. Let the universe unfold second by second without your supervision. You've done enough for today. This was why time is basically just math pretending to be physics. Brought to you by boring mathematics for sleep. Good night, traveller. Don't worry about tomorrow. Time's got it covered.